Welcome, everyone, to today's Harvard Data Science Initiative Industry Seminar. I'm Jen Chow. I'm Director of External Engagement, and I am delighted to introduce our speaker today. Bradley Fay is the Director of Data Science at DraftKings, the immersive sports entertainment company, perhaps best known for being one of the first daily fantasy sports platforms. Bradley joined DraftKings in 2018 and now leads the consumer data science team in building solutions for marketing personalization, product recommendation, and risk management. Prior to joining DraftKings, Bradley worked at Wayfair as a data scientist and has also been a high school teacher and a football coach. He received his MBA in sports business and PhD in quantitative marketing from Arizona State University. I'm going to invite Bradley to speak in just a moment, but I just want to remind folks that we use the Q&A function to take questions, so please feel free to add your questions during the talk. All right, thank you, Bradley, for spending some time with us today, and please take it away.
Hi, everybody. Thanks, Jennifer, for inviting me. Looking forward to sharing a little bit about how we think about data science and work at DraftKings within data science. So let me share my slides. Cool. So hopefully everybody can see that. But so the title of my talk today is called Building the Unbiased Subconscious of the Organization. And as Jennifer alluded to, I did my PhD in marketing, so there's probably a little bit of marketing flair on the title to make it sound fancier than what it really is. But hopefully by the end of this talk, it'll actually not be super overinflated. For today, what we're going to cover is I'm going to just give everybody a little bit of background about DraftKings. Not everybody's super familiar with everything we do, and I think it's good because it provides context about all of the different types of problems that we have to solve. And then I'm going to get into our frameworks of how we think about building decisions and building data science products at DraftKings, starting with like conscious and subconscious decisions, unbiased decisions, and then talk you through a quick example of how this actually looks in practice of what we do. I'm going to caveat this saying like me specifically doesn't know it, like everything. So definitely looking forward to questions and opportunities to kind of get ideas and thoughts and you know, learn. So cool. So, excuse me, starting a little bit about DraftKings. So DraftKings, the mission is to make life more exciting by responsibly creating the world's favorite games and betting experience. And the vision and how we accomplish that is we want to build the best, most trusted customer-centric destination for skin in the game fans to develop the most innovative and entertaining real money gaming products and offers, forever transform the manner in which people experience sports. So that's a word, a lot of words. So I'm going to tell you kind of my take on this. So, I've been around sports a long time, and I think one of the challenges with sports is, for the most part, it's passively consumed. We sit there, we watch it, we're told narratives by the announcers. That's what makes the game engaging. The thing that I love about what DraftKings does is it's taken that passive consumption and made it active. So now all of a sudden I can if you're in a state where sports betting is legal, I can place a bet, and now all of a sudden I'm cheering for an outcome that the announcers may not know about, but all of a sudden I'm emotionally invested in. And like where I became a firm believer of this is when I was in grad school, we used to go up to Las Vegas for March Madness. And I remember sitting in a sports book with like 500 people. And I think it was like BYU. And they were playing in a March Madness game. And they ended up hitting a shot at the last second. And they still lost by 17. But the entire sports book went just crazy. Like everybody was super ecstatic. And it's because they had all like had money and the line was right at like 16 or 17 points. And so by hitting that shot, it changed the outcome of a bunch of people won money to a bunch of people lost money and like vice versa. But anyway, it made that event and like consuming that event much more like engaging for those people who did it. And like since then I've kind of been, it's just fun. It makes sports like really, really interesting. What are the products that DraftKings has? So we have 4 products now. We just launched Marketplace this spring. But we started off with daily fantasy sports. That's how the company got started in 2018. When PASPA was repealed, we launched a mobile sports book. Which is probably what most people think about us now. In addition to launching a mobile sportsbook, we also have a mobile casino. So in certain states, you can hop on your cell phone and play, slot machines if you want to. And then most recently, we launched an NFT marketplace. So, we're always trying to innovate and trying to find opportunities to expand, ways for our core customers to engage, and NFTs were identified as a place that they seem to like. And, it's been a really interesting experience for us to partner with certain companies and doing that. But it's a new kind of venture. But yeah, all fun challenges in DraftKings world. A little bit more about where our offices are located. So we're multinational. So our headquarters is in Boston, but we have offices in New York City, Hoboken, Las Vegas. We have offices in London, in the UK, in Dublin. We also have offices in Eastern Europe. So Sofia in Bulgaria, and Plovdiv in Tel Aviv in Israel, and then Kiev. So unfortunately, we have a lot of our employees who are going through a really, really hard time right now. So it's made it interesting at work, to say the least. But hopefully, things will get better there. And then I just want to share a couple fun facts about the sports betting industry. I think this is, I don't know, I find it interesting. So the first one is, per Goldman Sachs, it's estimated that sports betting, from online sports betting, will be about $39 billion in 2033. So it's like a pretty big number. What I think makes it even more fascinating is, this is my favorite thing to ask people, is like, what is the margin on sports betting? And typically when I ask this in like friends and family, everyone's like, oh, well, whenever I bet I lose, so it's probably like 100% margin. The reality is it's not. Like across all sports books since 2018, the average margin is 7.3%. So that means for every dollar that's actually bet, we only make 7.3 cents, or sports books in general only make about 7.3 cents in general. So it's actually like a pretty thin margin. And it's like, once you kind of like get people to realize that, you understand like, oh, like any kind of like small change you can do to increasing marketing efficiency or increasing how well or effective we can make decisions with fewer resources, like is an improvement to how well we do business. So like that to me is also exciting. It's like that low margin actually means, from the data science perspective, we get a chance to have outsized impact on the business. It's also what's kind of mind-boggling is if you divide 39 billion by 7.3%, you can get a back of the envelope estimate of how many dollars Goldman Sachs thinks will be bet, and that's a rather large number of dollars actually wagered. So Jen gave you a little bit of background. I'll give you a little bit more detail just so you know who's talking to you. So I'm a director in the data science team. My team is really accountable for three main areas. So we talk about product recommendations. So it's when you show up to the site, what are the different things we can show you and how do we personalize that to drive engagement? Marketing personalization, very straightforward, right? Like we want to send somebody an email to drive them back to the site. We have 100 different things we could sell or say. How do we choose the right thing and choose it for the right person? And then risk. And risk for DraftKings really is twofold. So we have what we'd say is like putting the platform at risk. So, we take money and we wager. So like things like money laundering are a big deal for us. So we're trying to use data science to help identify when people are putting our own platform at risk by engaging in nefarious behaviors, if you will. And then the other area that we think a lot about is personal risk. So people putting themselves at risk, right? So like DraftKings is very, very into like responsible gaming and helping people understand, right? It's in our mission. We want to make sure people do this responsibly. So we're definitely thinking about how do we help people understand when they're putting themselves at risk and their well-being at risk, and using the data that we have available to like help make better decisions for their livelihood. Prior to moving to DraftKings, I was at Wayfair. A lot of my like kind of hands on the keyboard experience was helping build paid retargeting. So basically, how do you buy advertisements in real time, LTV forecasting. I did a whole bunch more. We'll kind of talk about it like a lot driven from like causal inference and how do you get good at experience. Just the one thing that the folks on my team who are here that may not know is like I was actually the employee of the year after my first year, which was kind of a cool honor. Yeah, I did my PhD. I did my MBA at ASU. I focused on quantitative marketing strategy. So I like to blend the econometrics and like to with the like pragmatic aspects of marketing strategy. Also while I was there, I actually worked full time for the athletic department. So I got to see that side of how, like the professional sports team or college sports team actually runs. Like how do the operations work? How do you actually generate revenue? And like doing things like naming rights analysis, and even got to, I guess the fun fact there is like, in one of the Final Four, qualifying to go to the Final Four, I actually got to be the person that handed the coach the trophy, which was like kind of a fun thing as I was running operations there. And then the last one is this is one that's like kind of non-traditional, but I actually started my professional career as a high school teacher and a football coach. And I say this not because it's like a huge deal, but I think it just gives a good color of my perspective and how I think about how we're building teams and how we're constructing teams and how we think about learning. But yeah, it's like, yeah, I guess I'm not the traditional, like coming from a comp side in Ivy League into data science. I came as a business teacher from the middle of nowhere in Illinois and have somehow ended up here and having a lot of fun. So how does data science actually look at DraftKings? So we have really three core areas of data science. So my team is here in the middle, right? We already talked about the consumer data science team. So we're talking about recommendations, marketing, and risk. On one side, we have the sports data science team, and they're based out of London. And essentially, what they're accountable for is like modeling the outcomes of games, and then using those models to build sports betting content. Right. So when you can go on DraftKings and place a bet that the Patriots are going to win by more than 7.5 points. That 7.5 points and the odds on either side of that are usually coming out of models that are built by our sports team. On the other side is we have a data science platform team that's highly embedded, and their job is to work closely with my team and the sports team and understand what our needs are and how do you help us build a scalable infrastructure. How do we define standards and practices around model building, model training, experimentation. Essentially, the high level problem statement is like, how do we do more with less while increasing quality, right? So like going back to like margins are thin, so we need to do as much as we can with what we have and continue to get better at that. In terms of like how we've constructed our team, we've thought about, we tend to think about data science as a very multidisciplinary field. At least like this is kind of from my experience. So I came at this discipline from a pure quantitative, right? I came from quantitative marketing, and everything was like, well, just give me a data set and I can fit a regression and tell you what to do. But the reality is to drive value for a business, you need a lot more than that. So we have a pretty diverse set of skills and backgrounds that are, focused in software engineering. We have, economists and people who are specialists in causal inference. We have people who are specialists in applied math and statistics. And we have people who are just like hardcore analysts who really, really understand how to think about what are systems that exist in the world or systems that exist in the business. How do we identify what those systems are and model and just like understand how those systems are working. And so we try and like combine all of those skill sets, and like that's how we drive it. But I like to talk about everything in like a football analogy, but it's one of those things where like when we build a team, we don't need 11 quarterbacks, right? We need people who are specialists in all these areas, and then we need to teach them how to work together and build complementary skill sets. And I think we do a really good job at DraftKings at bringing in these complementary skill sets and then training people up to drive value. All right, so getting into kind of the crux of the talk and why it's titled the way it is. So before we get started, I kind of want to talk about a little bit of a story. So I'm a father. I have 2 kids. My oldest kid is 4.5 years old, and he's just learning how to skate. And I was watching him the other day, and it was just very, very fascinating to watch. And like the first time he was out on the ice, he was thinking about every single move he's making, right? He's thinking about which foot do I move? How much do I move it? What happens when I move it? He's thinking about these things all in his conscious, right? Like it's very, very top of mind. And this is on day 1. And as we've gotten to like day 4 and day 5 of this, what I'm noticing is like those things that were very, very basic on that first day have like started to shift down, and they become more instinctual, if you will, right? Like he's kind of built them into his, what I would argue is the subconscious. He's taken those decision making and started to shift them down. And what that's done is that's unlocked his ability to focus his attention now on like, how do I start paying attention where other kids are on the ice? How do I start understanding how my momentum on the ice is going to like help me go faster or slow down? Like, how do I understand how to that? And then as he gets better at that, what he's going to learn is like those things are going to become instinctual, drive down into a subconscious. He's going to get into more complex problems of like, how do I start to navigate? What is the strategy of the offense? How do I contribute to all that? And I lead with that is because it's very, very fun to watch him take what are small basic processes, really, really focus on it, and then as he gets to be experts, he like migrates them down into his brain and then starts to like think about other things more complex. And the reason why we do that is because like that's the exact same way we think about data science at DraftKings, right? So we imagine that DraftKings is an organization that's always trying to learn, that's always trying to get better, and in doing so, like we have to make these like incredibly complex decisions. And in order to make those complex decisions scale, we need to figure out how do we like take them from conscious to the subconscious. So let me give you an example. So one of the challenges of the business is how do we grow market share, right? So one way to grow market share is, well, maybe the first problem is we just need to drive brand awareness. Not enough people are aware of DraftKings. Okay, so how do we decide how we want to drive brand awareness? Well, one way to do that is to buy advertising online. We can buy banner ads. Okay, so then we have to figure out how do we buy banner ads? Well, it turns out that you buy banner ads in real-time auctions, and you buy them on an individualized basis. So then you have to figure out how do I know how much to bid on a single advertisement for a single person on a single website at a given point in time that is going to be net beneficial for the organization. And all while like all of these like decisions are getting more and more complex, but the overarching goal is still the same. And it's like this kind of problem that we want to figure out, like, how do we make that scale, right? The first way to make it scale is you just throw a bunch of bodies at it. You get a bunch of humans, they're in there, they're thinking about it, they're studying the data, they're actually going through and trying to make manual decisions. And in the metaphor of like the conscious organization, I would argue like when a human is actually thinking about this problem and they're the ones that are proactively making decisions, that would be the organizational's conscious. And in order to free them up to do more sophisticated things, right, we want to think about like what are those processes they go through on a given basis. Like maybe there's some aspect of buying digital ads that we can take and we can put an algorithm behind it that can make that decision for them, so then they can go and think of more difficult problems, right? So maybe we can take away the need to buy and sell ads buy ads in real-time auctions. Maybe we can build an algorithm that has some heuristics or rules or even some machine learning models back behind it and powering that. And when we do that, that would be my argument. It's like every time we take one of those processes and we can shift the burden from a human making the decision to an algorithm or machine intelligence making that decision, I would argue that's migrating that to the subconscious of the business, right? It's decisions that are getting made, but we don't have to have humans proactively thinking about them. Like, sure, we're monitoring here and there, but if they're made correctly and they're built correctly, then what we've done is we've taken those resources up and we've freed them to go tackle more problems, to expand the breadth of problems, to identify other products that we should be supporting, to do all that. So I think like we're always trying to find where are the opportunities from our operational perspective where we can take situations where humans are making decisions. How do we encode those same decisions in the same logic that a human would apply in making those decisions, and how do we start to automate it and shift it down into machine intelligence, right? Like it's just like, I think of it as back in the day when factories started to introduce robots, right? The whole idea was like, how do you take a human off the assembly line and replace it with somebody who's consistent, who's repeatable, and all of these things, right? And you just kind of shift the burden. So when I first was doing data science, this also makes me laugh, is like my snarky example when somebody would ask me, well, what does it actually mean? And I was like, well, I would explain it as like, I would take people who are Harvard educated and I would try and automate them out of a job. Like, it's a little bit crass, but like in general, what I'm trying to do is like take highly complex decisions and we're trying to build a team around automating them and scaling them. So how do we do this and make sure we're doing it correctly? So I'm going to do a little bit of divergence and go into the construct of bounded versus unbounded rationality, because this guides a lot of how we think about this. So unbounded rationality or bounded rationality actually was like back in the day, it was like Simon like defined this construct and wrote a paper about it and ended up winning a Nobel Prize. But the idea was like, in economics, theoretically, if people have unbounded rationality, what they do is these complex equations in their head, this complex mental calculus, they'll look at all the possible decision alternatives. They'll forecast based on which choice I make, which one's going to provide me the most utility, and then they're going to choose based on what maximizes the utility. What bounded rationality helped us learn, along with everything that Kahneman and Tversky have done and Richard Thaler have done since then, is that that's not how people work, right? Like, people take shortcuts because it's a lot of work to do that math. It's a lot of work to do that mental calculus, and for every single decision in our life. And so what we do is we take those decisions and we push them down into heuristics, and we're kind of victim at that point of like bounded rationality because we have limited cognitive capacity and limited brain power. So as we're starting to automate decisions, we want to think about like, how do we automate them in a way that we can take advantage of this construct of like unbounded rationality? Because if we're taking it out of the hands of a human and we're putting it in the arms of like in the hands of mathematics or algorithms, then theoretically we can actually make everything as unbiased and as optimally seeking as possible. So we think a lot about that. So we basically, whenever we take a business process and we frame it down into something we want to automate, we start with just a standard like rational decision making framework. And the reason why we do this is because we want to avoid bias, right? Like, again, Kahneman and Tversky taught us that as soon as we start making decisions based on heuristics, all of these biases start to sink in. We have confirmation bias and recency bias and all of these different things. It was like one of the most fascinating things to learn in graduate school is all of these like things that cause us as humans to make bad decisions. But as an organization, we want to get rid of them. So the way to get rid of them is you just follow this process, right? So you start by defining the problem, you generate your alternatives, you identify the criteria necessary to judge each of the options. You weight them, you rate each alternative on a criterion, and then you compute the optimal decision. Sounds very straightforward. Again, if you ask like humans to go through and do this on a consistent basis, it's mentally taxing, and we can't expect them to really do that all the time. But if we're going to put this in math and we're going to put this in code, like there's no reason why we can't do this. So how does this framework map to data science and how we think about data science? So basically, I'm gonna kind of like link this framework, this process, to the various steps of a data science problem. So if you start with like defining the problem and generating alternatives, the way we operate at DraftKings is we rely on humans to define the problem. Like, what is the problem space that we need to solve? Like, what is the business trying to do? Is it trying to maximize customer engagement? Is it trying to minimize risk? Is it trying to maximize the number of these emails that get opened? What is that actual goal in the problem statement that we're trying to drive? And then we typically at this point, we rely on humans to identify what are the set of alternative paths that we can do, right? So in the case of sending personalized emails, we rely on our operations team and our creative team to come up with like, what are all the possible emails we think we might want to send? And essentially each of those alternatives is a hypothesis of like what we think is going to best solve the problem. So right now we operate in a world where that is all human driven. So then we get into the next three steps, and this is the machine learning phase. So the challenge of identifying the criteria necessary to judge multiple options, that's, you know, the analog there is like, what is your featured exploration process? So as you're building a model, like what are the predictors that you're going to use to predict your outcome variable? You know, the way I was trained, it was think about the data generating process. Like, what is the theoretical utility function? Like, what do people think about, or what aspects of the world should we consider when we're making these decisions and evaluating which alternative is the best? And then the step 4 of weighting the criterion, this is just training, right? Like when you fit a model, when you fit a regression, you're literally just letting the data tell you how to weight each of the criterion such that you maximize the likelihood that you're fitting the data correctly. That's the straightforward part, I think. And then the last one is how do you rate each alternative on a criterion? And this just becomes the prediction phase, or the inference, depending on what terminology you want to use. But essentially, once we have our fitted model coming out of step 4, then we can take that fitted model and we can say, how much value do we expect to get out of alternative A or alternative B or alternative C? And once we do that, then we can apply an optimization decision, right? So in the most simple case, we're going to choose the one that maximizes value for us. But one of the things that we try and do whenever we get into this optimization phase is we try and layer on constraints. Like, you can't always choose the best alternative possible because maybe it's too expensive. Maybe you only have a finite supply. Like, it would be great if we could give everybody a new car, but like we can't afford to do that. So you have to put some constraints in there. And so as we start to like encode these optimization functions, this is really where we're taking what is the logic or the decision function that the business would actually apply if it could talk, and this comes out of like discussion with stakeholders and data scientists and analysts and product managers. Like, what is the actual decision? How do we want to execute on that? And I think this is great because really what it ends up doing is it becomes this reflection of what is the strategy of the business. Do we always want to maximize revenue? Do we want to maximize revenue over certain time windows? Do we want to maximize engagement so long as revenue constraints are met? Like, there's all sorts of nuance, and there's no right or wrong answer, which is, I think, like very interesting because then you can experiment it and say, how do these map to the business strategy that we want to execute on? You run those experiments and then you see like, how did that strategy kind of pan out? And you don't have to worry about like, oh, well, you know, we didn't execute that strategy as well as we thought. It's like we put it in code, and if we all think the code, you know, maps to how we would execute in all possible situations, then we did, and it could have just been like a flawed strategy. So it becomes a much more objective way to evaluate strategy from the way we think about it. So when we automate rational decisions, and how do we do that? Like, really what we're trying to find is like, if we choose X, what is the actual impact on Y? And so this is another critical piece of how we think about this, of like, we want to know what is the unbiased relationship between our decision variable X and our outcome variable Y. So in the world of machine learning, we talk about the bias variance trade-off. Like, we will take all of the variance in the world so long as we minimize the bias of our estimate of that relationship between X and Y. Because what we want to do is we want to know that if this process is running in the background, it's doing what it thinks is best, even if there's a bunch of error. It's doing what it thinks is best in expectation, in an unbiased way, right? We don't want it to, like, if you train on some weird endogenous thing, like, you don't want it to affect them. So how do we do this? Well, we ground everything in causal inference, right? So we don't just do pure machine learning. We basically build everything from a causal inference framework perspective, like causal inference number one, right? Like at the end of the day, we're automating decisions. Those decisions we expect to make with some kind of expected change in some outcome variable, which is perfect for the causal inference. I know there's a big group and I was super excited when I was like scanning the site. There's a big group investing in causal inference, and I like couldn't be happier. I've been talking about this for years, so it's glad that more and more people are thinking about it. But for now, we stay just as like kind of some details. Like we stick with the potential outcomes model. YI when treatment is 1 minus YI when treatment is 0 is kind of your treatment effect. We haven't really gotten into the Pearl model of do calculus. It just hasn't been a necessary thing. Like we're still trying to. We think we can be sufficient here, but it's definitely an area where we're trying to consider. Obviously, when you're doing causal inference, random control trials are the gold standard. So we do as much as we can in trying to try and generate random control trials as much as possible. For anybody who's done experiments in the field, because everything we do is in the field, we don't have clean laboratory settings. Getting clean random controlled trials are it's almost like this mythical unicorn of like, oh, in the social science in the field, we can get like a pure random control trial. So since we don't, we augment our limitations of our experimentation with econometrics, right? Like econometrics and statistics and epidemiology, those are all areas that have been trying to say like, well, when you can't do randomized controlled trials, how do you still tease out causal effects? I'm super happy to see, John List and Guido and all those guys win Nobel Prizes this year for doing field experiments. It was like nice and validating. Like, yes, we're going down the right path, but that's it. So the way we think about this too is there's like two dimensions, right? So the more rigorous you can run an experiment, the less sophisticated the analysis can be. So if you get a pure randomized control trial, you can just do a t-test or z-test and like your results are clean. You're going to get an accurate measure of effect. You could throw in some covariates if you want to shrink the error around your effect size to get them more confident, but you don't really need to do a lot. The beauty of that is our stakeholders understand it, and it makes communicating the value like really, really easy. Like I said, the unfortunate part is like we usually end up somewhere in the middle from an experimental rigor standpoint. There's usually some sort of limitation, whether it's like one of the common ones in marketing for sure is compliance issues, where like I intend to treat everybody with an email, but I cannot make everybody open the email so they're not exposed to the amazing creative that I have, right? If you don't account for that in your analysis, then what you get is like a bunch of people who in your test group look like they didn't have an effect, but they couldn't have an effect because they were non-compliant. They didn't actually receive the treatment. So that requires us to go up, increase our level of sophistication and analysis. And you get into things like using instrumental variable regression and different diff methods. And fortunately, there's been a lot of development in that area. So we have a lot of opportunity to grow there. But the challenge there and why we try and like avoid that if at all possible is it's much harder to communicate with stakeholders, right? Like it's hard enough to explain two-stage least squares regression to somebody who's doing a master's or PhD in economics, like when they're first or second year, let alone somebody who is not doing that. And that's not the thing that they're the most passionate in the world about. So we're trying to balance all of these things all the time about like, how do we use the right methods so that we're getting unbiased results, but how do we do it in a way that we can still communicate about how the models are working? Because what we don't want to do, or what we're not really allowed to do, nor should we be, is taking these decisions, putting them in this black box that, we can just kind of hand wave and say like, oh yeah, it's unbiased, and then letting it go, right? We're not just going to let this thing make decisions without any kind of monitoring whatsoever. So it's on us that we have to demonstrate this. And so we spend a lot of time thinking about how do we build causality into our frameworks? How do we debate, are we actually getting the true unbiased estimate? How do we do all of these things? And it's like, there's folks from my team that are watching, and they can probably like get tired of me talking about it all the time, but like it is the thing that we are trying to do. Because really what we want to get to is we want to get to modeling heterogeneous treatment effects. So this is our holy grail for data science. And the reason why HTEs are our holy grail for data science is because when you have heterogeneous treatment effects, it means when you make a decision in an automated way, it means you have to apply nuance, right? It means that certain groups of users are more impacted by one alternative than another, and the other group of users is more impacted by another alternative, right? Like it justifies the value of personalization, right? There's like at the end of the day, personalization, the value of personalization is the hypothesis, and the hypothesis is validated by the fact that if there exists a heterogeneous treatment effect, then that validates the need for personalization. If it's just a globally optimal treatment effect, you can just show everybody the same thing, and it's not that big a deal, which is great. Like if that's the case, but I think it's hard. It's a hard pill to swallow. That everybody would be most impacted by the same treatment when there's 100 set of possibilities. So for us, getting as much rigor into our modeling such that we can tease out this heterogeneous treatment effects is incredibly important as we're starting to build these systems that are taking operational decisions and shoving them into the subconscious. Cool. So then the next thing is like, that's the kind of frameworks that we take. So now what kind of problems do we take on? So essentially what we're trying to find are where are bottlenecks in the business, right? Where are issues that human capacity, where we just can't hire enough people, right? So you can imagine when we get a bunch of customer experience tickets right at the beginning of the NFL season, because we have a bunch of new accounts registered and we have to verify licensees to make sure everybody's, who they say they are. Like you can scale that up with human capacity, or you can try and automate that with machine intelligence. Right now we use humans because that's the right thing to do, but like eventually there's opportunities there. Other bottlenecks are complexity. At some point, like the relationships within the data are so complex that like our brains can't comprehend them very well, right? Like I mean, that's part of the challenge of getting a PhD is like you're trying to like explain these like incredibly complex relationships, let alone understand them so well that you can then take repeatable actions on them. It's just hard. But what you can do is you can do this in math and you can do this in algorithms and you can code it and evaluate it over the series of times. So you get into the kind of the metagame. We find situations where repeatability of the decisions matter a lot, right? So like if you want to make the same decision, you want to apply the same policy over and over and over again, like repeatability matters a lot. And then the last one is adaptability. So like one of the things that I find just like most fascinating about DraftKings and the challenges that we face at DraftKings is we're a highly seasonal business. The customers that we have on site today are fundamentally different than the customers we had on site at the beginning of the NFL season. And so the models that we have that work today don't work necessarily in the NFL season. So we have to build systems that adapt. And you have to build systems that can adapt as quickly as possible. So we're thinking all about like adaptive experimentation and multi-arm bandits and how do we inject those where we need to go, and how do you think about sequential trials? Because at the end of the day, like a lot of the work that we're putting on is like, how do you know what works best during NBA season, and how do you know what works best during NFL season, and how do you balance those understandings about like what's like best for the company, and hopefully you can kind of understand like there's so many moving parts that it's hard to keep straight, even like for me to try and explain it, let alone for an operator to like keep that mental model in their head and like execute repeatable decisions against that framework. Cool. So let's finish up with just like a quick example of what this may look like in practice. So for us, so I'm going to jump from sportsbook to casino, honestly, just because the graphic that I found for casino missions was like more appealing than the graphic that I found for sportsbook missions, but it's the same mechanics. So essentially what we have is whenever you come to our site, you can click a button on the casino app and you'll see what we call a mission. And essentially we've tried to gamify part of the application. So we ask people to engage, say, for example, play 20 hands of blackjack. And when you do that, we'll give you $5 in free play as a reward for doing that. And so you can imagine like the business strategy that we're trying to address is like, one working hypothesis is that the best casino has the most variety. And if you have the most variety, then no one would ever need to leave your casino to go choose to find the right slot machine or find the right blackjack table. They should always be able to find it there. Well, if they don't know you have the variety, like they're not going to know that they don't need to go anywhere else. And so one way to illustrate that they have variety is to incentivize them to explore. And so that's like one of the mechanisms that missions can kind of help with. So how does this like fit into our framework that we just used about bottlenecks? Well, essentially, one of the challenges is we want to give a new mission every single day. So if a human has to go through and manually assign a mission to 1 million different people every single day, that's just a lot of work in our system to go through and do. So one, seems like a good opportunity for us to like take that conscious decision and like shove it into the subconscious and automate it. Two, we want to personalize the content of the mission to ensure its relevance, right? If I play, if I'm a casino and I happen to be a high roller, which I'm not, and I'm playing $500 hand blackjack and you offer me a $5 reward, it's probably not going to appeal to me because that's like a rounding error in a single bet that I make. So we want to make sure we're understanding that and we're providing rewards and providing experiences that are engaging and incentivizing to users. And so like we want to take into that. But like that's an example where like you can't just like broad strokes like give everybody the same mission and expect it to be valuable, right? So like we're pretty confident there's heterogeneity in the treatment effect there. So we want to account for that. We have new customers every day, right? And those preferences vary every day. So even in casino, we see seasonality in our customers. So this is where we need to adapt, and our algorithms need to adapt, is like the changing preferences as our customer. And this goes into the last one, is like we're also adding new games all the time, right? So there's new content, there's new ways to like push people to try and like introduce them to new opportunities to explore. And how do we do this in an effective way? So when we do this in data science, like before I kind of like close this out, but I can kind of tell you like basically what we have here is a system that in order to do all these things, we need to run rapid experimentation. We need to adapt. We can't just do pure A/B testing, because you're necessarily going to show people that are missions that are irrelevant when you know they're irrelevant. And then you all have to like, we have to like figure out how do you take all that data and create it back in a feedback loop, right? So like we're running multi-arm bandits, and we're using Thompson sampling, and we're using, oh my gosh, I'm blanking. We're correcting for the selection bias by using propensity score matching, right? Like we can do all these things, and we have the system built out to where it can learn, and it can learn in an unbiased way. And so for us, it's super valuable, because what we don't want it to learn is like, well, when it starts to assign one mission more and more and more, we don't want it to learn that that's the best mission because it thought it was the best mission. We want to learn it's the best mission because it drives the behavior change that we think it's going to drive the most. Cool. All right, so we're going to finish, I think, on time. So just to kind of summarize, just key points about how we think about it is perceive, we can kind of conceptualize the organization as its decision-making being, right? Where the brain is like all of these people making decisions every day. We try and find the high-value conscious processes where people are actually making them that are current bottlenecks of scale. And we want to automate those decisions, because we want to take those people who are making those, and we want to free them up to take on more challenging things, to launch new products, to identify new challenges, to identify new ways to better serve our customers, and to give them that responsible opportunity to engage with our product. And we do this by focusing on causal frameworks, because this helps us ensure that when we migrate rational decisions, or migrate these conscious decisions to the non-conscious, that we don't introduce bias, right? We don't become heuristic decision makers. We want to make sure we maintain that rational decision making, and we don't let bounded rationality kind of bite us in the rear end, where we end up like, 6 months from now, this thing has been running, and like, oh my gosh, it's kind of gone off the rails. So to kind of summarize, like we've been doing all this stuff. So back to the analogy of skating. As a company, or as a team, we are, kind of in the midway of our skate. We've learned how to skate. We've learned how to skate with direction and turn and stop and whatnot. But we still have a lot to do, and we have a lot of opportunity to do to grow for the business, and to create value there. So we're just like really trying to have fun and get better every day. And I'm gonna call this out, but like this was supposed to be a picture of my kid in a GIF, but we were told we can't use kids for sports betting. But I'm gonna still shout out to Baker. But yeah. So with that said, I'm happy to answer. It looks like there's like a few questions, so we have plenty of time.
Yeah, I'll let questions trickle in. Folks, remember to use the Q&A so that we can collect your questions. I have a question though in the meantime,
Sure.
Which is, as you think about entering new markets, regional markets, or maybe new products, how do you think about robustly, transferring what you're learning into those new regions or new products?
It's a great question, right? So like I'm gonna sort of answer this a little bit indirectly, but I think it gets at what we do. So like one of the big challenges we have is like states are not the same. Like there are cultural differences, there are team preference differences, and so like what may work in one state may not work in another, right? Like you can just look at one of my favorite things is look at like which states spend more money on lottery, and that kind of gives you like a signal of like risk profile for the state. So one of the other challenges for us is like once a sporting event has happened, it will never ever happen again, and it has never ever happened again in the past, right? So we don't technically have training data. So if we were like Amazon or we were Wayfair, once we sell a couch, like that couch is the same. It stays the same. So like everything we learn about that couch for one person, we can transfer it to another person. But let's say if the Lakers play tonight, that game and like all its like nuances with like coming off losing games and the number of points and injuries has never happened in the past and never happens in the future. So we have to work really hard on like how do you embed all of these things that we're trying to make decisions on in like common state spaces, such that you can compare events and you can compare states, right? So like the challenge of states is what are the things that are similar that you can say like, okay, well, here are the commonalities of these states, so we think these things might work. and then what are the things that are different. In that case, like it's like, okay, well maybe some of these other things won't work because of these differences, and so we want to make sure we're experimenting super fast to learn what actually will work.
And this is kind of a related question then is how does DraftKings account for users now having access to advanced stat models from places like ESPN? When you're thinking about, you know, how someone's going to interact with the platform, do you take that into account?
Um, I would say no. I mean, like reality. So like honestly, like sports betting is essentially an information asymmetry game, right?
Right.
Right. And so like whatever they have access to, we have access to as well. And so essentially at that point, it becomes who can model it better, right? And like that, people who are good at sports bettors have an edge because they either have access to information that like we don't have that we use to build our models, or they understand how to model it better, right? And that's where like edge comes from. Essentially, like you can predict which side of the coin is going to be biased better than the person flipping the coin.
Right.
So like it is like implicitly accounted for in the way that we build our models. So assuming we're using like similar information, we're incorporating it similarly. But like we don't like explicitly say like, oh, well, so and so went to go visit advanced stats from ESPN, so we think they're a sharp. Like,
Right. Um, this is an interesting one. Do you have any measures of social harm from your platform? Control groups of places where you are versus match locations where your platform is not permitted on such things as personal bankruptcies, divorce rates, suicide rates. You know, it's your risk. It's the question of risk.
It's a great question, and I can't really give you a good answer. I am not the expert internally. We have a director of responsible gaming, Christy Thurman. She was actually used to be at Harvard. She ran the research laboratory at Harvard, who would be a much better person to answer that question. So like, I'm gonna dodge it mostly because I don't want to say anything incorrectly. But it is like a good question to ask.
Let's see. Here's a more general question. What resources do you recommend for a business leader to take a non-data scientist dive into causal inference and gamification? Do you have any suggestions?
There's one book that doesn't get recommended enough, but I like swear by it. It's a book called Prediction Machines. So it's a couple business professors out of Toronto wrote it. Avi Goldfarb, and I actually have it back. I can look, whatever. It's published by Harvard Business anyway. I would argue for any business leader who wants to understand the value that data science can drive for the company and like how to think about it, it's by far the best book that I read of all the things. It's not technical. It gives you similar, honestly, like a lot of the framework that we take has been influenced by that book and how those professors have kind of thought about it and articulated it. Mostly because it resonates with me and the frameworks that I like use to think about the world. So I would say like Prediction Machines is probably the best book. If you want a technical deep dive, there's another one called Business Data Science. Matt Taddy wrote it. He was an econ professor at Chicago, and now I think he's like leads economics at Amazon. If you want a technical deep dive, that's like probably the best place to start.
I'm sure folks appreciate those recommendations. We have a question here about odds. Curious about how odds are set early on in the process. So, for example, when it was first known that Georgia would play Alabama for the football game, how were the odds set? How much risk does DraftKings take early on versus later? I'm actually not sure if those are related. I apologize.
Okay, so I'm going to do my best to give you an answer here, but I wish my colleague Robin was here. He would be a much better person to answer this question. So essentially what happens is as soon as you know who the teams are playing, we can go through and we can take our models and we run our models, and that kind of gives us an estimate of like what we think the outcomes of the games are. The other thing you have to look for when you're making book is like, what do your competitors say? And so you have other sportsbook, like offshore sportsbooks like Pinnacle and BetCris. We have onshore sportsbooks like FanDuel and PointsBet that we all want to take into account because while even if you have the best model possible, there's like some like you get into these like weird economics and like creating additional volatility if your odds are too different than your competitor odds. And it's because the incentives are like you get unbalanced risk on either side. So essentially like that's how it is. And in terms of like when you take risk early versus later on, so the way I would think about this, and this isn't like DraftKings specific, but just like from being in the sports betting industry is there's a concept in sports betting called the closing line. And essentially it is, what are the odds that the bookmakers are saying like are the true outcome of the game at the moment that like a game kicks off? And there's a theory that says that is the most efficient line. So and that works in like what we call highly liquid markets. So a highly liquid market is where people bet a lot of money, right? So like the national championship game, the Super Bowl are like highly liquid markets because a lot of people are betting money. And the way to think about it is those lines are efficient because there's so much money being bet, and every dollar bet is essentially a vote for like what is the true outcome. So essentially you get like the wisdom of the crowds working to tell you what the like true outcome or true expected outcome is. And in doing so, what it really means is like earlier on, you tend to take more risk because the odds of you being incorrect, because you don't have that information of where all the bets are going to come in, are higher than they are like as you get closer to game time.
I think it's interesting. It really is drawing from the wisdom of the crowds in that sense.
It's a really like we talk about this all the time internally, like the closing line and what you place odds at. Very on like there's a couple good articles on Pinnacle sports betting. If you want to learn about sports betting, the Pinnacle sports betting blog is a good place to go. But talk about like how do you measure if you're good or bad, and like a lot of it has to do with can you get an advantage over the closing line. So essentially, can you find out when the odds are inefficient early on, and do you tend to find that the odds are inefficient early on in bet? And like even if you're not winning money, like you're statistically still ahead of the game. And so it's like, you know, if I flip a coin, we know the outcome's 50-50 heads or tails. But if you can get ahead of the game, you can flip that outcome to like 51-49 or 52-48. And like that's where like even if it comes up a bunch of tails, it's still probable. But like over the long run, you're eventually going to end up with more heads than you do tails because you know what that difference in bias is.
So here's a question about bias. How do you measure your bias and variance for models? What tools do you use and how frequently do you do it?
I wish I had a more sophisticated answer. So really bias is, at least when we think about it from causal, like you try and evaluate the methods and you anchor in the methods and the methodology and the people who have done all the work on that. Because you can't ever observe ground truth. And like, that's the hard part for us, right? Like is you can't observe ground truth. So the best thing you can do is you could simulate data where you know the ground truth. You can apply the methods to the data where you know the ground truth. And if you can recover that, then you have faith that the methods, assuming that the synthetic data you generated was generated in a manner analogous to real world data, that you have confidence that you would actually recover the unbiased estimate in the population, whatever that may be. But it's all about like there's a lot of assumptions you have to make to get there, and it becomes this like really interesting logical argument of like, are you actually recovering an unbiased estimate?
Right. Okay, well, now here's a question about modeling, I think. So the participant writes, I was interested in your early comment about the London team building models to try to predict the outcomes or set point spreads for specific games. At some point, I had learned a vague model that what sports books were really doing was setting, for example, point spreads to try to balance the actual payouts in terms of the current betting patterns, and then make a profit on the VIG.
Yep, the VIG. It's like so much nomenclature.
I'm learning all this new terminology. Can you comment on these two different approaches?
It's the price. Okay, so what I think, Richie, what you're asking about is like the construct of like if you had a single market that you were taking a bet on, your goal would be to not necessarily perfectly model the outcome of the game, but would be to model the median of demand such that you would have balanced demand on either side, and you essentially price in whatever like the VIG such that like you use the wins, or sorry, one side of that coin flip is going to win, the other side is going to lose. Use the money that you keep from the losers and you pay out the winners. Like that's balanced betting. In a one-shot game, that makes sense. If you think of this in terms of like repeated trials, that actually becomes what it ends up doing is like there's again on Pinnacle, like they've been doing this for a while. But if you read a couple articles, like essentially theoretically caps your upside because you're not taking advantage of much of the variance. So like in the long run, you want to continue to model like the best outcome of the game. And you want to do so even if the market becomes very imbalanced, right? So like whenever we like have a Patriots game, or like when like Patriots play, right? Like in the New England area, people tend to bias towards the Patriots, right? In the New York area, people tend to bias towards the Jets or the Giants. So you get like irrational like betting on one side or the other. Like you can't get rid of that. And like in the long run, you're good as so long as you're priced efficiently and like you model efficiently. There's some like math you can work out, but like again, Pinnacle is like they've been doing this for a while and they're really good.
You know, maybe what we'll do is after this, if you have some resources for folks who want to learn more about sports betting generally, maybe we can send those along.
For sure. Yeah, there's a lot of good articles. There's a really good book called The Logic of Sports Betting. That if you want like a great place to start to understand how the industry works, how bookmaking works, how betting works, and there's the difference in being good at betting and the difference at being good at bookmaking. That's a really great book to check out.
All right. You know what? I think we've actually run out of questions.
Cool.
So I just want to thank you for your time, and thanks to all our participants for those thoughtful questions. Coming up on March 29th, we have a fireside chat celebrating the Data Science Initiative's 5th anniversary. It will feature Kamsal Bayezid from the CEO of Elsevier and Kara Swisher from the New York Times. And our next industry seminar will be April 14th with Toyota. So more details are on our website. We hope we'll see you then. And with that, I think I'll bring this session to a close. Thanks, everyone, and have a really great afternoon. Thanks, Bradley.
Thank you.